now let us proceed to erosional landforms. So we are now going to proceed to erosional landforms. So tulad nga ng sabi ko, class, pag sinabi natin erosion, ito yung process kung saan tinatransport natin yung sediment from one location to another. So now, marami tayong possible agents of erosion. Maraming possible agents na pwede mag-transport ng sediment from one location to another. And we will examine only two lang, dalawa lang agents yung examine natin. And those agents are the following. We have wind and water. So these are the most common agent of erosion. So the most common agent of erosion would be wind and water. Itong dalawang to, the wind and water is the most common agent of erosion. So we will examine yung mga erosional processes due to wind and the erosional processes due to water. So pag yung erosional process natin is due to wind, tinatawag siyang aeolian erosion. Aeolian erosion, and yung landform na nabubuo niya, we call it as the aeolian landforms. Samantalang pag water naman, it can be two kinds, Pwedeng due to running water, yung mga stream natin, so we call it a stream erosion, Stream erosion, at yung landform na nabubuo niya would be stream, not stream may tamang term doon. I forgot the right term or the correct term. Pag yung landform is formed by the stream erosion. So let me check for a while, I forgot it. It's not here. Anyways, I forgot the proper term, kung yung landform na form ng stream erosion. But what is certain here is that yung tawag natin sa erosion na nangyayari, class, due to running water, tinatawag natin siyang stream erosion. And kung due naman, class, dun sa waves, dun sa ocean natin, tinatawag yun as coastal erosion. At yung landform na na-form ng coastal erosion, tinatawag yun as the coastal landform. So tulad nga ng sabi ko, we have many agents of erosion, and yung most common would be wind and water. But aside from wind and water, these are other possible agents for erosion. We have, so we all know already, running water. We have glaciers, Meron tayong glaciers. Later on, we will discuss that, One would be biological agents. An example would be man. So ayun, this is erosion or the transport of sediment due to running water. Dito naman, this shows wind erosion or the transport of sediment via wind. And class, ito naman, the transport of sediment via the movement of the glaciers. Yung movement ng ating glaciers. Okay, now, ano ba yung mga pwede nating i-transport na sediment? What are the different sediments that we can transport? So these four are the four possible sediments na pwede natin i-transport. Ang pinakamalaki would be the solid sediments, So the solid sediments would be the largest sediments that we can transport, And the smallest sediments that we can transform are actually your ions, Ions ang pinakamaliit na particle na pwede natin i-transform. So these are the four common sediments that we can transport, We can transport soil, So let me write this one para maliwanag. So ito yung mga sediments na pwede natin i-transport via erosion. Number one, yung soil. And soil particles can be silt. Let us take first clay, not silt. Clay, silt, and sand. Ulitin ko. So tulad nga ng sabi ko, meron tayong apat na klase ng sediment na pwede i-transport by erosion. And the first kind of sediment that we can transport is your soil. And your soil class can vary, Yung particle niya pwede mag-vary. It can vary from clay, silt, and sand. Yung clay ang pinakamaliit sa lahat ng soil particle, while the sand is the largest among all soil particle. Now, aside from soil, pwede rin tayong mag-transport ng tinatawag nating solid sediments. Ito yung mga bato, the solid sediments. And solid sediments, so yung sabi ko, sila yung bato, that includes boulders, yung cobbles, Cobbles is mas maliliit na bato kumpara sa boulders, no? And pag mas maliit pa sa cobbles, tinatawag naman yun na pebbles, no? And pebbles. So those are the different solid sediments that we can transport. Now, we can also transport the colloidal particles. Ito medyo maliliit na to, no? Yung mga colloidal particles na tatawag natin, at ang pinakamaliit sa lahat, no, would be the ion. So this is the smallest sediment that we can actually transport. Now, if you are going to look at the graph, pinapakita sa graph na to, no, kung gaano kabilis na transport yung particle and gaano kalaki yung particle. Gaano siya kabilis na transport at gaano kalaki yung particle. No? So what do you notice? What do you have observed? In this diagram, ang pinakamaliit natin sa diagram na to would be the clay particle, followed by the silt particle, the sand particle, then the pebbles, cobbles, and the largest would be boulder. Tignan nyo sa clay. In order to transport clay, you would be required with a small amount of velocity only. So meaning, mababa lang yung velocity ng water or ng wind na kailangan mo to transport clay. Kasi nga maliit si clay eh. Pero as you go to silt, tignan nyo yung silt, sand, dito na yung sand, dito na yung pebbles, dito na yung cobbles, dito na yung boulders, no? Sorry, ito pala yung boulders, dito yung pebbles, cobbles rather, dito yung pebbles, dito yung sand, dito yung silt, dito yung clay. So what do you observe, class? Habang lumalaki yung particle natin or yung sediment natin, pahirap siya ng pahirap i-transport. You would be required with higher velocity of water or higher velocity of wind in order to transport the particle or sediment with increasing size. So meaning, ang pinakamadaling i-transport si clay, no? In this case, kasi wala tayong ion dito, ang pinakamalit dito would be clay. The most easiest to transport here would be clay kasi class, it would only require a small amount of speed or velocity of wind or water. Pero ang pinakamahirap would be boulders, yung malalaking bato, due to the fact na kailangan mo ng mataas na speed of wind or water in order to transport these boulders. So, meaning class, the relationship class of the particle diameter and the velocity of the agent of erosion class would matter in transporting or eroding these different sediments. So, unahin natin yung wind erosion. Pag sinabi natin wind erosion, ang nagtatransport ng sediment would be wind. And class, the material that is able to be transported class by wind could vary also from small particle to large particle depending on the wind velocity. At class, ang tawag natin sa landform na nabubuo ng wind erosion, tinatawag natin siya class na Aeolian landform. Let me repeat myself, we call it class as the Aeolian landform. So tatandaan ninyo to class mas madaling i-transport yung sediment ng dry na lupa kaysa sa moist na lupa. Okay. Dry sediments class or dry land is much easier to transport or to erode than moist land. Kaya nga class, kung mapapansin nyo sa mga countries na deserto or sa countries na dry yung lupa, ang ginagawa nila, they try to make their soil as moist as possible so that hindi siya madaling ma-erode. Kasi sometimes erosion could be cause of disaster. Pwedeng maging cause ng disaster. Meron siyang risk na pwedeng dalhin sa specific geographical area. And to avoid that risk, kadalasan, ang ginagawang mitigation ng mga country na deserted or not deserted, sa mga country na yung lupa nila is dry or they are in a desert area or yung geographical area nila is desert, they are trying to make their sand or they are trying to make their soil as moist as possible so that it cannot be eroded quickly. So ayan class, so if you would observe yung mga sediments natin due to wind erosion. In wind erosion, usually the sediments The sediments are transported in a way that it bounce, it jumps and it bounce. Ayun, tignan nyo. The sediments are jumping and bouncing class. So ganyan mag-travel yung sediments natin due to wind erosion. So usually the sediments, no, lalo na yung mga larger sediments in wind erosion, it travels by what? It travels in a way that it jumps and bounces. So in this case, kung titignan nyo dito, it usually jump and bounces. The sediments usually jumps and bounces. And the rule here is that, kung babalik tayo dito, kung ito yung mga sediments natin, the easiest to transport with wind erosion would be clay. So mas greater yung distance na nararating ng clay and silt. Samantalang yung sand, pataas, no, mas shorter yung distance na nararating nila. And the usual motion class na sediments dito, lalo na yung mabibigat na sediments, will be jumping and bouncing. So yun nga, just like what is shown in the picture, the sediments here are jumping and bouncing as they are being transported from one location to another. And usually yung mga landforms na nabubuo natin due to wind erosion, tinatawag natin siyang aeolian. We call them as aeolian landforms. Unahin natin, yung abrasion. Let us take first wind abrasion. Tulad nga ng sabi ko kanina, di ba? Pag sinabi yung abrasion, yung mga sediment, no, pwede silang tumama sa parent rock, causing the what? Causing the disintegration of the parent rock or the rock body. So dito sa wind erosion, pwede siya magkaroon ng tinatawag natin na wind abrasion. Kung saan yung wind nyo class, it is able to bring small sediments, no, or it can bring sediments to the parent rock body, causing it to disintegrate. No? So anong nabubuo natin? Anong nabubuo nating mga landforms due to this wind abrasion? Anong klase ng landform yung nabubuo natin? So we are able to form what we call as bentifact. So tinatawag ng bentifact, and pag sinabi niyong bentifact, this is an example of a rock body kung saan yung rock body pinalish siya ng mga sediments by wind abrasion. So by wind abrasion, no, this rock body is polished, no, and pag na-polish yung rock body natin or parent rock natin by wind abrasion, tinatawag siyang bentifact. Now, the bentifact can be flattened into two surface or three surface. So, pwede siya ma-flatten into two surface or three surface. Pag two surface siya, tignan niyo yung spelling ha, pag dalawa yung surface na nag-flatten yung ating rock due to wind abrasion, tinatawag siyang encounter. Ulitin ko ha, pag dalawa yung face na nabuo ng ating wind abrasion or kung dalawa yung face ng bentifact natin, tinatawag natin siyang encounter. Pag tatlo naman yung face ng bentifact ninyo, tinatawag siyang dry canter. So in this case, now we have encounter and dry encounter. So ito class, this is how many faces. We have one, no? We have one, two, ilang faces to? Dalawa, no? I'm not mistaken, this is two faces. So this is an encounter. And ito class, titignan nyo, may tatlo siyang face, 1, 2, and 3. So this is a dry canter. We have 1, 2, and 3 face. Ay hindi, tatlo pala face nito, ito pa pala. Sorry, I did not notice this one. So it has 3 faces. We have the first phase, the second phase, and the third phase. Kung may tatlong phase yung Kung may tatlong phase yung bentifact ninyo, tinatawag yan na dry canter. Pero kung dalawa lang yung phase niya, like in this case, ito dalawa lang talaga. We have one, ito yung pangalawa, we have two phases, tinatawag siya na encounter. And in this case, dahil tatlo yung phase niya, we have dry canter. So let me repeat myself pa. Yung nabubuo natin by wind abrasion, tinatawag yun na bentifact. No? Again, the rock body that we form or we smoothen during wind abrasion, tinatawag natin siyang bentifact. At ang bentifact natin, pwede siyang maging encounter. No? Pag encounter, there is only two phases. No? Pag dry canter naman, meron siyang three phases. It has three phases. So in this case, no, meron siyang tatlong phase. We have phase 1, phase 2, and phase 3. So tawag dito is dry canter. Ito naman, dahil meron siyang dalawang phase. We have phase 1 and phase 2. Tinatawag siyang encounter. So it would depend on the number of phases. Now, maliban sa bentifact, yes, Josh, what's your question?
Sir, may possibility po ba na maging more than 3 yung phases po niya?
That's a good question, no? May possibility pa. The thing is, hindi. Kasi usually three-dimensional lang naman yung rocks. So nangyayari, yung flattening niya can happen only up to three dimensions only. So it can happen kung ang na ano lang na flatten lang would be two dimension, would be the front and the sides lang, that would be two faces. Pero kung ang na flatten would be top, side and front, that would be three faces. So that would result to a dry canter. Kung side, top, and front lang yung na-polish niya. That would result to three faces or the dry canter. Pero kunyari, dalawang sides lang, that would be eye canter. So it cannot be in a way na magkakaroon siya ng more than three sides kasi three-dimensional space lang yung tinitignan natin sa rocks. We are not looking at higher dimensional spaces at hindi rin possible yun na magkaroon ng higher dimensional spaces yung rocks ninyo. So kung STEM kayo, maaaral nyo to ng Chem 2 eh. Lalo na yung mga crystal structures, saka yung crystal structures ng rocks ninyo, saka paano yung cleavage niya. Thus, makikita ninyo doon na meron lang possibility na up to three phases lang. Three phases lang. No? Hindi siya possible na more than three phases. Okay, do you understand, Josh?
Yes po.
Okay. So let us now go to the next aeolian landform that we can form by wind erosion. Yung tinatawag nating yardang. So dito naman sa yardang, ito yung parent body nyo but na-polish yung sides niya. Ayan no. Both sides are polished, no. So ang nangyari because of polished sides nangyari, class, nagkaroon kayo ng elongated ridge structure. So if you would observe the polishing at the sides, no, produce an elongated ridge structure, which can say, class, that the direction of the wind, class, is parallel to the ridge that it formed. So kung ito yung ridge nyo, ito yung ridge na nabuo nyo, yung tatawag natin yardang, meaning nito, class, ito yung direction ng wind ninyo. It is going here at this direction. It is parallel to the prevailing wind, or the yardang that you are able to form is parallel to the prevailing wind. So ang nangyari, class, it is also formed by wind abrasion in a way, class, na yung sides natin were polished, and because yung sides natin yung na-polish, class, upon wind abrasion, class, ang nangyari, nagkaroon tayo ng production of an elongated ridge rock body, and this elongated ridge, tinatawag na siya yardang. And usually this yardang is parallel to the direction of your prevailing wind. Now, sometimes may tinatawag rin tayong mushroom table or pedestal rocks. So nangyayari to, class, pag yung mga sediments na dinadala ng wind erosion is heavy. 'Di ba, class, isipin nyo, kung mabigat yung mga sediments na dinadala ng wind erosion, meaning nun, class, saan lang matatransport yung mga sediments? Sa ilalim lang. So nangyayari dito, dahil nga mabibigat yung mga sediments na dinadala ng wind erosion, ang nangyayari, ang nadidisintegrate nyo lang is yung nasa ilalim. Hindi nyo nadidisintegrate yung nasa taas. So this happens, class, when abrasion only happened, class, at the bottom portion of the rock body and not at the top portion of the rock body. And in this case, kung ang inyong abrasion nangyari lang sa bottom part ng rock body, nakaka-form kayo na tinatawag natin mushroom table or the pedestal rocks. So tinatawag silang mushroom table or the pedestal rocks. And in this case, yung wind abrasion, saan lang nangyari? Wind abrasion just happened in the lower portion of the rock body and not on the upper portion of the rock body. And we can infer from that na yung mga sediments na dinala ng wind abrasion na to would be a heavy sediment. And since heavy yung sediments natin, class, ang na-disintegrate lang or ang nadurog lang would be the lower portion of the rock body or the parent rock and not the upper portion of the parent rock. So this is another example of a mushroom table or a pedestal rock kung saan yung abrasion nangyari lang saan. The abrasion just happened at the bottom part, or yung greater amount of abrasion nyo or erosion just happened on the lower portion of the rock body or the parent rock. So tawag din is mushroom table, no, or the pedestal rocks. Now, sometimes, class, may mga malalaki tayong sediments, no, yung mga cobbles, pebbles, and boulders. Sometimes na iipon sila sa isang lugar, and pag naipon sila sa isang lugar, tinatawag yun na desert armor. We call that as desert armor. Okay, another example, no, let us say mabibigat masyado yung sediment. So, dahil mabibigat yung sediments, mangyayari, class, malakas yung impact pag nagja-jump and nagba-bounce yung mga heavy sediments. So, the jumping and bouncing of heavy sediments causes what? Causes the breaking, no, or the disintegration of your sandstone, for example, in this case, sandstone or other rocks, no? And in this case, pag ganun nangyari, pwedeng magkaroon tayo ng depression. Dito, tignan nyo, kung mapapansin nyo, nagkaroon kayo ng depression in the rock body due to the fact na yung pag-bounce dito ng malalaking sediments, nag-cause ng disintegration. And this disintegration causes the formation of this depression, no? Kung saan tinatawag natin itong depression na to as the deflation basins. Then, tinatawag natin yung depression na to as a deflation basins. And sometimes these deflation basins later on, no, let us say umulan, these deflation basins can be filled with water. So in this example, itong mga depletion basins na to, nabuo to ng abrasion or ng wind abrasion, kung saan yung mga large particle, it's able to what? It's able to disintegrate the rocks or the parent rock at this portion due to the jumping and bouncing movement of the heavier sediments. Yun yung tinatawag natin na mga aeolian landforms. So anyways, class, no, let us have a final overview of the different aeolian landforms that we try to look at. So we have the small deflation basin, no, yung ating desert pavement or yung desert armor natin, the pedestal rocks, no, the ventifax that includes the encanter and dry canter and your yardang. So these are the most common aeolian landform that is formed due to your wind erosion or due to your aeolian erosion. Okay, do you follow? Grade 11, do you follow? Grade 11, nakasunod? Bago ka mag-proceed sa stream erosion. Maliwanag naman?
Opo.
Okay. Let us go, class, to stream erosion. So, tapos na tayo sa wind erosion. We are now going to water erosion. Yung mga erosion natin due to water. So, yun nga, tulad ng sabi ko, it can be due to stream erosion or running water. O pwede siyang mangyari sa coastal areas. No? Itawag natin coastal erosion. Let us look at stream erosion. So, tatandaan ninyo, class, no? Your stream usually looks like this one, no? Yung stream natin usually looks this one. Ito yung iba-ibang pattern ng stream natin. So, what is with streams? So, kindly remind this yourself that streams are channels streams are channels where water can pass through. And usually, itong mga streams na to, they are made up of several branches, no, that is part of a single system. And later on, class, itong mga several branches na to, they would collect all the runoff water, class, sa mga branches na to, and would lead to a single system later on. So, for this example, no, so ito yung iba't ibang klase ng stream drainage pattern na tinatawag natin. And tulad nga ng sabi ko, pag sinabi yung stream, they are channels, class, where water can pass through. And usually itong mga stream na to, meron silang branches, class, that later on would collect to a single system. So technically, itong mga branches na to, later on, all of those would collect to a single system. Thus, lahat ng water na papasok sa branches, later on, would collect to a single system. No? And usually, class, itong stream na to, it is where water passes through and it drains water from the land going to the water system. So, kinoconnect niya yung land ninyo doon sa water system ninyo. Kaya nga, class, kung mapapansin ninyo, yung mga ilog ninyo, yung mga rivers ninyo, connected siya saan? Connected siya lagi sa dagat. It's connected to the ocean. The reason for this is that your rivers and your streams are actually the connection, class. It's the connection between your water and your land. Kasi, class, nagsaserve yung mga rivers natin as a drainage for water or for runoff that will be present sa lupa natin. Di ba naalala ninyo, class, pag umuulan, bumabaha? Ang tawag natin sa baha na yon, tinatawag natin yan na runoff. Ngayon, the question is, saan napupunta yung baha? Where does it go? dumadaan yung baha na yon dito sa mga streams. It passes through these streams. So meaning the runoff water, yung tinatawag natin baha, papasok yun sa stream system ninyo, sa iba't ibang branches ng stream system ninyo that would later on collect to a single system that would lead class to the water system. So technically, yung mga stream ninyo, it's connected usually sa water, and this streams class connects your water or your water system to your land. So siya yung nagiging drainage ng run of water natin. And the thing is, class, dahil nga may dumadaan ditong running water, dahil kinoconnect class ng mga stream systems natin or ng stream natin, class, yung land and water, sometimes class, yung mga sediments natin, it can be transported through these streams or through these stream systems. Pwede siyang matransport class through these streams. So yun yung tatandaan ninyo. This stream class is actually a basin or a channel class where runoff water can be transported from the land, no, galing sa land class, going or galing sa landmass going to the water system. And yun nga class, that's why class, kung mapapansin niyo sa mga dagat, sometimes connected yun sa rivers. It is connected to the rivers kasi class, yung rivers ninyo or the stream systems are actually systems class that connect your water or your bodies of water to your land so that yung run of water natin, it could re-enter your hydrosphere. It would not stay in your landmass, no, but it would go class or it would flow to your hydrosphere. But the thing is, class, dahil nga nagiging daanan yung stream system natin, it can be an agent for erosion. It can transport sediment from the land, no, from the land masses going to the water system. And in this case, class, sometimes nade-deposit yung mga sediments natin along the way when it passes through your stream, no, habang dumadaan siya sa stream natin. And yun nga, class, tulad ng sabi ko, may iba't ibang klase ng pattern. There are many patterns of stream drainage. So kung mapapansin niyo, ito yung iba-ibang klase ng stream drainage natin. We have the annular pattern, the parallel pattern, the trellis pattern, rectangular, dendritic, radial, and braided pattern. So itong annular pattern, ito yung pattern na usually nakikita natin sa mountain. So nag-start siya sa tuktok ng mountain. That's why kung mapapansin niyo, class, ayan, no, it start at the peak of the mountain. Meron tayong 4 na branches dito that would later on collect to a single system. Ito naman class, tong rectangular, nangyayari ta sa faulted area, sa mga area na may faults, no? Okay, we also have the dendritic pattern. Sa dendritic pattern naman, this happens in your flat area. Kaya siya maraming branches kasi nga, so that it would allow water to flow in a flat area. Pag radial naman, mountain rin to. This is another pattern or drainage pattern found in mountain and volcanoes. And class, kung makikita ninyo, maraming branches, no? There are many branches for your streams, no? But class, although there are many branches, later on, they would collect to a single system. And this single system would lead water from the stream system class going to the bodies of water. Bale, siya yung nagiging connection ng lupa natin, ng landmass natin to the bodies of water. But yun nga, tulad ng sabi ko, dahil dinadala niya yung water or yung run of water galing sa lupa, papunta sa bodies of water natin, sometimes sediments are transported along with it. What are the different characteristics of streams? Number 1, yung streams ninyo, lagi siya nag-flow downhill, pababa, no? Lagi siya nag-flow downhill. So, ibig sabihin, kung nag-flow siya downhill, it is flowing from a narrower basin going to a more wider basin, and nag-flow siya from higher area to lower area. Ulitin ko ha, let me repeat myself. Stream is flowing downhill. Yung mga stream natin, it is always flowing downhill. What do we mean, class, by the stream is flowing downhill? Ibig sabihin nun, yung water natin, nagta-travel siya, it travels from a narrow area going to from narrow area going to a wider area. And also, aside from traveling from a narrow to a wider area, yung stream nyo rin, it travels from a higher slope So going to a lower slope. So nagta-travel siya downhill. So yan yung ibig sabihin na the stream is flow or the water in the streams flowing downhill. Ibig sabihin ng class, yung water natin sa streams natin nagta-travel siya from a narrow area going to a wider area and from a higher region going to a lower region or from a higher slope going to a lower slope. So for you to understand that fully, let me draw the structure, no? Let me draw the structure of the stream.
Okay, great. Well, let us stop our synchronous session. Can you finish the activities? Do not answer the remaining. Okay, so when you finish, you still have 40 minutes of it. We'll end the session. Okay, I'll be sending to you the link later. User Gerald, maybe about sa webinar on plagiarism, okay, academic dishonesty. Okay, so
Okay, ito class ha. So tatandaan ninyo, in your stream system, sabi natin, one characteristics of stream system is that the water is always flowing downhill. Meaning, galing siya sa narrower area going to a wider area. So usually, ang structure ng stream system nyo would look like this. So mag-start siya at a narrow area. No? Mag-start siya at a narrow area, then mag-end siya at a wide area. So that's one criteria no para masabi natin that the water in the stream system is flowing downhill. So ang pag-flow ng water natin is from a narrow to wider area. And another thing that you should look at is the slope. Gaano kataas yung lupa. So as you go further away, no, as you go further away, habang nag-flow yung water natin, nanggagaling tayo sa mas mataas na region dito. No? Nanggagaling tayo sa higher slope going to a lower slope. No? It's going to a lower slope as you go further away, class, from the source of water. So meaning class, ibig sabihin niyang class, no, na yung stream system natin, the water there is always flowing downhill due to the fact that it's flowing from this from this narrower area going to a wider area and from a higher slope to a lower slope. And if that is the case, meaning the potential energy there, yung potential energy natin is being converted to kinetic energy over time. That is why masasabi natin it is flowing downhill. Meaning nangyayari class, pag flowing downhill, hindi tayo gumagamit ng energy to make the water flow. It would just flow naturally due to the fact na kino-convert natin yung potential energy to kinetic energy and not the other way around. Kasi kung ang gagawin natin, kung yung kinetic energy, ang gagawin natin potential energy, that is uphill. Meaning gagamit ka ng energy to make the water move. But in this case, you will let the water move naturally by converting the potential to kinetic energy. And paano nangyayari yon? By traveling from a narrower to a wider area and from a higher slope going to a lower slope. So yun yung isang characteristic ng mga stream systems natin. Okay, meron din tayo class na tawag na stream discharge. Pag sinabi niyo naman class na stream discharge, pag sinabi niyo naman class na stream discharge, ito yung amount of water that is passing pag sinabi niyo stream discharge, ito yung amount of water or the volume of water passing through a point in the stream. No? So if this is an example of a stream, no, sa illustration natin, balik tayo sa illustration natin kanina, here in our illustration of the stream, let us say we will examine this point, no? We will examine this area. Let us say we are going to examine this area. Now, pag in-identify natin yung volume of water that is passing through this point, class, in your stream system, tatawagin natin yung class as the stream discharge, no? And from this stream discharge, we can we can be certain about the stream velocity of water in your stream. So meaning class, pag alam niyo yung amount ng water or the volume of water passing through this point along the stream, pwede nating ma-identify yung tinatawag natin stream velocity. Gaano ba kabilis yung water natin, gaano kabilis yung water natin sa ating stream at that point. So the thing is, the rule here is that habang dumadami yung water na dinidischarge, as you increase the water discharge, habang tinatasan yung stream discharge na tinatawag natin class, as you increase the stream discharge class, nag-i-increase din yung tinatawag natin stream velocity. So, ibig sabihin ng class, pag tumataas yung stream discharge or yung amount of water class, amount of water, the volume of water passing in one point of the stream, meaning tumataas rin yung velocity ng stream natin. So that is another property or that is another characteristic of your stream that you needed to know. Now, why is it important? Mahalaga to class because it has something to do with the transport of sediment. Di ba class, naalala ninyo, sabi ko sa inyo kanina, nakadepende sa stream velocity yung pag-transport natin ng sediment. Kasi kada klase ng sediment, for each kind of sediment class, it would require a certain speed class of wind or water for it to be transported. So meaning, pag mababa yung stream velocity or mabagal yung movement ng stream natin, hindi niya kayang mag-transport ng larger sediments or larger particle. Pero class, the thing is, pag mas mataas yung stream velocity natin or simply pag mataas yung stream discharge natin, ibig sabihin nun, the stream class will be capable of transporting larger sediments. So the thing is, class, if you have greater stream velocity, pag mataas yung stream velocity natin, class, keep this in mind, kung mataas yung stream velocity natin, the larger the particles that we can erode. Pero class, kung mababa yung stream velocity natin, if our stream velocity would be low, class, ibig sabihin nun, maliliit lang rin yung particles na kaya natin i-transport or yung kaya nating i-erode. So that is our rule here for the transportation or the erosion of sediments in our streams. For a while. Okay, so let's continue. So what we have discussed so far, class, are your streams, yung nature ng streams ninyo, and class, the characteristics of your stream. So alam na natin na pag sinabi natin streams, they could vary, they could vary depending on the drainage pattern. But what is certain is that itong mga stream na to, class, are usually comprised of what? It's comprised of basin class that serves as a connection between the land and the water system. So kinoconnect niya yung lupa ninyo and your water system ninyo, thus transporting the runoff water, yung runoff water na tinatawag natin from the land going to the bodies of water or going to our water system. Thus, these basin class are very important as drainage, as water or runoff drainage sa lupa natin. And usually, to be an efficient or to be an effective water drainage system, kailangan marami siyang branches. And these branches, class, can vary depending on the topography of the land. So may iba-iba tayong klase ng drainage pattern as shown in the picture and as what I have discussed a while ago. Now, class, so, itong mga itong mga drainage pattern na to, if you would observe, there are many branches for efficient water drainage. And class, these different branches later on would connect to a single system that would lead to the water system. Alam na rin natin, class, nabanggit ko na rin sa inyo kanina yung iba't ibang characteristic ng stream natin. And tulad ng sabi ko, how do water in stream flows? How do water in streams flow? They flow downhill. Ibig sabihin that they flow downhill, hindi tayo gumagamit ng energy to make water flow. Instead, we are just converting our potential energy to kinetic energy to make the water flow. And this is achieved by traveling from a narrower area or a narrower channel, going to a wider channel, and from a higher slope, going to a lower slope. Another thing that you must remember that yung mga geologists natin, there is a way class kung paano nila ma-measure yung volume of water na pwedeng mag-pass through a point in the stream. And we call class the amount of water passing through a point of the stream, tinatawag natin class yon as the stream discharge. And yung stream discharge na to could help you determine the stream velocity na tinatawag natin. Yung sinasabi ko sa inyo stream velocity. And the stream velocity would depend on the stream discharge. Pag mas maraming volume of water ang dumadaan sa isang point, mas mataas yung stream velocity. Pag mas konti yung amount of stream discharge or mas konti yung amount of water that is passing on one point, mas mababa yung stream velocity natin. And this is very important, especially in water erosion, kasi class, nakadepende sa stream velocity yung transport nating sediments. And that what is shown here in this diagram or in this graph class na pag mas maliit yung particle, mas madali siyang i-transport. Mas maliit yung amount na stream velocity, ayan o, you would look at this one class and you would see na stream velocity yung factor sa x-axis na pag nakita ninyo to, pag mas maliit yung particle, mas maliit yung stream velocity na kailangan to transport it. But as you increase the size of your particle, there is a greater amount of stream velocity needed, no? Na kailangan ninyo to transport this particle, which means class na related sa stream discharge yung pag-transport ng ating sediments. Meaning, pag mas mataas yung stream discharge nyo, that's the time that you can transport particles with greater size. And pag mababa naman masyado stream discharge, meaning non-class, you can only transport small particles there. I think class, we lack time, so we will continue our exogenic processes next meeting. So we will continue on our stream erosion. Tutuloy natin stream erosion natin next meeting. So, so far, did you understand the lesson? Naintindihan naman?
Yes po.
Maliwanag?